So to determine if these two functions are inverses, remember we need to check. We need to check that f composed with g is x, and we have to check that g composed with f simplifies down to just x. So starting over here, that would be 3 times 1/3 x minus 2 plus 6, and then distribute, and hopefully this simplifies down to just x, and lo and behold, it does. Okay, so that's good, but we also have to check both. So if we do that, let's see, g composed with f will be 1/3 3x plus 6 minus 2. Distribute the 1/3. Oops, that's a 2. And sure enough, this gives us x also. So yes, they are inverses because both are true. If even just one of these did not work out, then the functions would not be inverses. They both have to be true. Now here, when they say write an equation for the inverse function, that's the same thing as them asking us to find the inverse, find f's inverse. So remember, you want to start by making that y equals x squared plus 3. And it is important to notice that we do need x greater than or equal to 0, because if we didn't have that, then this graph would include the left side. If it included the left side, it would fail the horizontal line test and it wouldn't be a one-to-one function. But we need a function to be one-to-one in order to even have an inverse. So that's why we need this, so that we don't use that half and then it is one-to-one. And then your next step would be to switch all x's and y's, including in that condition. So we're going to need y to be greater than or equal to 0. And now solve for y. So if we subtract the 3 over, and then square root both sides, but remember when you take a square root, you're supposed to consider the plus or minus possibility. But we said that this is for when y is greater than or equal to 0, meaning positive or 0. Which means we only want the positive square root. Okay? Because of that. We do not want the negative square root in this case. So this is the inverse. If you didn't have enough space to write that there, you could write that down here. That's just fine. And if we graph this function, well, remember the square root of x. This is what's in my mind before I actually draw our function. I remember that root x looks like this, and this this minus 3 right here will shift us 3 to the right. So that means we'll be right there and right there, because this is 0, 0, and this is 1, 1. So this is going to be 3, 0, and this is going to be 4, 1. And that's the inverse. And if you look really closely, it does kind of look like the black line is a reflection of the blue line across the red diagonal.